Dude, did you know that the sun is a third generation star?
What does that mean?
It means that the sun formed from gas and dust which was created and left behind by at least two other stars that lived and died before it. The sun is a recycled star. It was assembled from the ashes of its ancestors.
Really? How would we know that?
Well, we can tell because of what the sun is made out of. See, there are many different ways in which we classify stars, and the one that's relevant here is classifying them based on their metallicity.
Metal what?
Metallicity, man. It's just a measure of how much metal a star contains.
Stars have metal in them?
Yes, but probably not in the way you think. See, a metal in astronomy is just every element on the periodic table which is higher than helium. So, according to astronomers, we are made of metal.
Why is that?
Well, because the vast majority of atoms in the universe are hydrogen and helium. Those two alone constitute 98% of all of the observable matter in existence. And stars are clear examples of that. They're almost entirely composed of just those two, with only a smidge of heavier elements mixed in. So it's really just for convenience in astronomy to be able to say that a given star is 99% hydrogen and helium with just trace amounts of various metals.
Okay. So how can we even know what stars have in them?
Yeah, just through one of the coolest things about the universe. The fact that a star's chemical makeup is encoded within its light. See, one of the most common things that astronomers do is collect the light of celestial objects and then break that light up into all of its constituent colors by passing it through a prism or something like a prism. And they do this because the spectrum of colors that, say, a star gives off is never perfectly continuous, but rather it's always missing certain colors. And it's these missing colors, what we call spectral lines, which reveal what the star is made out of.
How?
Well, because of how atoms work. See, due to the way that electrons occupy different energy levels for the various elements on the periodic table, every element absorbs and emits its own unique set of wavelengths or colors of light. And so by identifying the various elemental fingerprints within a star's spectrum, we determine what it has in it. And through careful analysis of how weak or prominent certain lines are, we can also understand how much of a given element is present. Is that not amazing?
It is really cool. Okay, and so if a star has lots of metal, what does that tell us?
A lot. For one, a star's metallicity gives us a sense of how recent in cosmic history it must have formed, because the amount of metal it possesses is an indicator of how many stellar generations must have come before it.
How?
Because here's the key. The only way that metals come into existence in the first place is by being created in stars. See, the universe in its earliest years didn't contain any metal at all, because the only elements that resulted directly from the Big Bang were hydrogen and helium. It wasn't until stars began forming out of that hydrogen and helium and generating their energy by fusing those atoms together that heavier and heavier elements were gradually created. And only after the explosive deaths of the earliest stars was the universe provided with metals for the first time. So then it's pretty straightforward, dude. If a star contains any amount of metal at all, we know that it formed, at least in part, from the remains of dead stars.
That is incredible.
It's like the coolest thing ever. So yeah, over the course of cosmic history, the universe as a whole has progressively become more abundant with metal, as ongoing cycles of stellar death and rebirth have continued populating galaxies with more and more of those heavier elements. And so if a star is really high in metal, we know that it must have formed fairly recently, unlikely, cosmically speaking, because the only way in which a star becomes metal-rich is if the material from which it formed had been chemically enriched by several generations of stars. This is the case with our own sun. It's what we call a population 1 star, the class of stars which are metal-rich. Now, on the other hand, if we measure that a given star is really low in metal, then that must mean that it's incredibly ancient, as the material from which it formed evidently hadn't yet been through many rounds of this cosmic recycling process. These are known as metal-poor population 2 stars. But what about stars that don't have any metal in them at all? Stars which formed out of nothing but the hydrogen and helium generated by the Big Bang itself, the very first generation of stars ever. Metal-free population 3 stars. Well, we've never actually found one of these stars, nor have we yet detected any direct evidence of their existence.
Wait, what?
Doing so is among the many frontiers of astronomy. We're working on it, but man, are they really hard to find.
Why?
Well, because back when these first stars existed, the universe was a very different place.